Question 19. Prove algebraically that the sum of squares of two consecutive integers is always an odd number. Now the key here is algebraically, you can't just give examples. So what we can say is, we're talking about any two consecutive integers, so we can say let my first integer be n, and therefore my next integer is going to be n plus 1, so 1 along from it. And the sums of the squares, so n squared, n add 1 squared, and the sum of means we add them together. So this is going to be n squared add n add 1, n add 1. And so now I can multiply out these brackets. So n times n is n squared, n times 1 is n, 1 times n is n, and 1 times 1 is 1. So this is going to give me 2n squared add 2n add 1. So if I look at my 2n squared add 2n part, if I factor out the 2, I've got two lots of n squared add n and then add a 1. And what I know is that this part must be even as it's a multiple of 2. Because whatever my part inside the brackets here turns out to be, I'm then timesing it by the 2 here, and it will turn out to be an even number. We've then got an even number plus 1, and that must equal an odd number because they go odd, even, odd, even, odd, even. So therefore we've shown there must be